everyone, this is Dude Blender. Let's jump right in. As always, try to watch the whole video as there are tips and tricks that if you miss, might mess up your animation. To make this 10-band visualizer, you'll need a sound clip. You can download one from Pixabay for free. I'll leave a link in the description. First, we need to make a geometry for the actual bars. I will do a rectangular prism, but you can really do any shape you want. I'll use a bevel modifier to soften the edges. In this exercise, I'll be mapping the sound to the Z-scaling to make sure that the origin is on the base of the shape. But note that you can use any variable, size, position, even color in your project. Now let's do the shading. I want to make a gradient from green to yellow to red, add some light emission to it, and I want the colors to be revealed as the bar grows in size. So you should only see the yellow and red on the louder sounds. So add a material. I will call this one sound bars. Go to your shading workspace and make sure that you're in the material preview viewport shading so that you can see what you're doing. Shift A, texture, gradient texture, then Control T to create the texture, coordinate, and mapping nodes. Of course, you need to have the node wrangler enabled to do that. Connect the object connector to vector, and with the eyedropper, select the shape that you're working on. This bar will only be used as a shading reference. You'll see why in a minute. Connect the color connector from the gradient texture node to the factor of a color ramp node, and connect the color to the base color of your principled BSDF node. Now, if you stretched and rotated your object, select it and press Ctrl A, rotation and scale. This will apply both transformations. On the mapping node, change the Y rotation to 90. It should look something like this. Now, these couple of steps are a little tricky as the values that you'll use depend on the characteristics of your shape, but we want the gradients to cover the whole height of the shape. Here, a big part of the shape is completely black or white, and there is just a little part of actual gradient. The way I do this is scale in Z, and by the way, remember to hold shift while dragging for more precision. Scale down until the top half of the shape is covered in gradient. Don't worry if it's not 100% exact, we'll fix it later with the color ramp. Now change the location X so that the gradient is in the middle of the shape. Then scale in Z again until the gradient covers the whole shape. Repeat once more if necessary. Now let's add the colors in the color ramp. Feel free to use whatever colors you like best. I like to change the interpolation to ease, but change it to whatever looks better for you. Make any final adjustments to your colors. To add a bit of light, Shift A, Shader, Emission, and place it near the principled BSDF. Now Control Shift, right click and drag from one shader to the other to add a mix shader. Connect the colors to the emission shader, and now go to the rendered viewport shading. Make sure you have cycles as your render engine. Change the factor on the mix shader to whatever you like best. I think from 0.5 to 0.8 looks best. But Blender's your oyster, so you do you. As I said, this shape will be our shading reference, so place it outside of the frame. But make sure that you do not move it in the Z direction, because doing so will change the mapping. It's not a big deal, but you'll have to map the colors again. Also make sure that the origin of your shape is on the base, as we'll be scaling up and down the Z axis. You could leave the origin in the center of the shape, you would just have a different effect. Last thing to check is your frame rate. Make sure you're using the correct one, because once we map the audio, we cannot change the frame rate without having to remap audio all over again. Take a sip of tea or juice, and let's move on. Go back to the layout workspace and duplicate your shape with Shift D 10 times and place them in your scene. You can turn on snap to increment if you want them to be very neat, but of course place them in a way that works best for you. Just make sure that they are all on the same plane, don't move them on the Z direction. I'm gonna place them in a line, but it also looks cool if you place them around the circle. Now we'll need to map the audio to each individual bar one by one. Now very quickly, a few notes about working with frequency. The audible range for humans is from around 20 to 20,000 Hz. Every sound can be broken into sinusoidal waves of different frequencies that if you add up, recreate the sound. We'll map ranges of frequencies to each bar so that we can visualize the whole spectrum. Each octave doubles in frequency, so this C key in a piano will have double the frequency of the C key of a lower octave. Keep those points in mind. Make two small horizontal windows in your workspace in addition to the timeline that you should already have. Change them to Graph Editor and Sequencer. Make sure that you're in the first frame by pressing this button or shift left arrow on your keyboard. Select the first bar, the one that will show the lowest frequency. Press N if you don't see this window and make sure that you're in the item tab. Right click on the Z scale and insert single keyframe. Make the graph editor window larger if necessary. Click on this triangle and expand to see all the channels. Make sure that the Z scale is selected. You can click out to deselect everything and then select the Z scale channel just to make sure. Go to Key, Bake Sound to F curves and navigate to your sound clip. Do not bake it yet, we need to select the frequency range first. Leave the lowest frequency at 0, but change the highest frequency to 31.25. With this, the first shape will only react to frequencies between 0 and 31.25 Hz. Attack time is how long the shape will take to scale up when the sound is played. Release time is how long it will take to go back to its rest position. You want the attack time to be really fast, so the default value is okay. And depending on how slow you want the shapes to scale down, you can change the release time. I think that between 0.2 and 0.5 is good. Make sure that whatever numbers you choose, you use the exact same in the other shapes. Blender saves the changes, but still double check. Leave the rest of the fields with the defaults. Now click on the Bake Sound to F-Curves button. The shape flattens, which is the reason why we made our shading reference separate, to always be able to see it in case we want to modify something. You'll see in the graph editor that the audio has been mapped to the Z scale channel. And if you press play or spacebar, the shape will start reacting to the sound. To be able to hear the sound, go back to the first frame and in the sequencer, add sound and select your clip. Now if you hit play, you can hear the sound and see the shape reacting to it. Pretty cool if I say so myself. Go back to the first frame and select the second shape. Insert the single keyframe in the Z scale and then key Bake Sound to F-Curve. You should see the values you used in the first shape. Now copy the value of the highest frequency and paste it to the lowest frequency field. Then multiply the value on the highest frequency times 2. You can do the operation right there in the field. Click on the Bake button. Repeat this step for all the shapes. If you do it correctly, you'll know that the last shape goes from 8,000 to 16,000 Hz. And you might ask, hey, didn't you say that we can hear up to 20,000 Hz? The answer is yes, we're just using the standards for equalizers. But you could change the highest frequency on the last bar to 20,000 if you want. Now, if you ever want to do this with more or less frequency bands, you can Google, let's say, 20 band equalizer and just use those values. Or if you like math, you can use this formula. The starting frequency band is the highest frequency in your full range divided by 2 to the power of the number of bands minus 1. So in our case, our highest frequency was 16,000 Hz and we have 10 bands. So 16,000 divided by 2 to the power of 9 equals 31.25. Then we just double each time. Blender allows you to animate almost any variable, so you can use this technique to animate colors, shape keys, materials. It's really up to your imagination. Now you just need to render your work and you're done. That's it for today. Drop a like, comment and subscribe if you like this video. I'm Dude Blender. Happy blending!